Hello, I'm Dr. Deepthi and we are discussing different concepts from mathematics under the heading Decreations Mathematics. Linear combination is an important concept in maths. So let us have a look at it. The word combination suggests that there must be some adding up of components. Now here the components are vectors and they are also multiplied by scalars. So if you have a set of vectors, say from v1, v2 up to vk, that means a set of k vectors, then any vector is a linear combination having the form c1v1 plus c2v2 plus dot 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 plus ckvk. That means what is happening here? There are k vectors v1, v2 up to vk. Each one of them is multiplied by a scalar. For example, v1 is multiplied by a scalar c1. v2 is multiplied by a scalar c2. vk is multiplied by a scalar ck, etc. And then those terms are, or those product terms are added. Let us take an example. For simplicity, let us take a set of only two vectors, v1 and v2. Let the scalars be 4 and 3 respectively. Then what do you have to do? Multiply the first vector by the first scalar 4 and v1 are multiplied to give 4v1. This is the first product term. Then 3 is multiplied with the second vector, that gives you 3v2. And when you add them up, 4v1 plus 3v2, that essentially gives you the linear combination of vectors v1 and v2. Let us explore it further. So the key term to remember is v is equal to c1v1 plus c2v2 plus and so forth plus ckvk, where v1 to vk are vectors and c1, c2, ck, etc. are scalars. Now let us imagine that, let us take the further example, 4v1 plus 3v2. And now here the vector itself has three components. For example, the vector can be written as 5x plus 13y minus 15z. Similarly, vector v2 can be written as x minus 3z. Notice here the second component is 0. Now if you want to combine them, how will you do it? You just have to concentrate on the respective components. So when you want to get the first component of the vector v, you have to multiply first component of v1 with 4. That means 5 is multiplied by 4. And first component of v2 is multiplied by 3. That means 1 is multiplied by 3. So what do we get? 5 into 4 and 1 into 3. What does it give you? 20 plus 3, 23. That's how you get the first component. If you want to get the second component, again 4 into 13 plus 3 into 0. So 52. Similarly, third component, can you find it out? Yes. 4 into minus 15 is minus 60 and 3 into minus 3 is minus 9. So minus 60 minus 9 minus 69. So you get the entire vector 23, 52 minus 69. Now you can do it for other combinations also. For example, you can try to solve it for the linear combinations 3v1 minus 19v2 minus 7v1 1 by 5v1 plus 2v2. Now you might wonder that when you say v is equal to minus 7v1, is it really a linear combination? It is, because here the scalar c2 is considered to be 0. So if you say, you can call it as minus 7v1 plus 0v2. So that again gives you the same linear combination. So remember that linear combination is multiplication of vector with the corresponding scalars and combining it together through addition. So V is equal to C1V1 plus C2V2 dot 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 CKVK. So easy concept to remember. In the further episodes, we will look at the details of it. We will try to solve a question. Also, we will look at linear independence and linear dependence, which are important concepts which emerge from this linear combination. Thank you.